Last thing we want to look at for 1D kinematics is solving problems of constant acceleration. In this situation, let's say we have a ball being dropped, then we want to set up this table to look at what we know and what we don't know. If I think of the ball as being dropped and I want to know something about it, maybe a certain time later or a certain distance later, I can use this table to find out what's going on. Now, if we define up as positive, then the force of gravity is downward, and therefore my acceleration is negative, and it happens to be 9.8 meters per second squared. If I'm holding the ball and letting go, then I can say I start at time t equals 0, my initial position is time t equals 0, and my velocity is time t equals 0. Let's say I want to find out where everything is in a certain time. Well, I'm going to have three variables that I don't know: the final time, the final position, and the final velocity. Generally speaking, I really do know some of these items in order to do the problem. Now, let's say I want to know where is it after 3 seconds. Then I know my TF. And I can find, using the equations of constant acceleration, the final position and the final velocity. So in this case, let's say I want to find my position. Equation number 1 would not help me. Equation number 2 looks very promising because I want to find position. I know velocities, accelerations, and time, so that looks promising. And equation 3 could be, but I don't know my final velocity and I don't know my displacement, so I'm going to say that would not help me. So let's take equation 2 here and say xf equals, now what's my initial position? Well, it's 0. Okay, so that goes away. Plus vi delta t. What's my initial velocity? That's 0, so that goes away. Now my final term is 1/2 a delta t squared. So xf equals 1/2 minus 9.8 meters per second squared times my 3 seconds, that's my delta t squared. That's how I would get that value. So the final position is 44.1 meters below the origin, which is at the starting point. So the ball fell downward, so that has a negative sign. So this technique is very powerful because it helps you identify what you know and what you don't know in the table, and then it helps you select which one of the 3 equations you can use for your particular word problem. Hope this helps.